Hello guys, welcome back to calculus class. This time I will go over FRQ non-calculator portion. So question number 3 has only A, B, and C, and so is question number 4. Keep that in mind. I'm not expecting you guys to finish every single question of this one, but lucky enough, this one is not that difficult, especially number 1. All right. So it says the depth of the sweater at location can be modeled by the function h that satisfies the differential equation. Actually, not sweater, seawater, I'm sorry. This, where h of t is measured in feet and t is measured in hour. After net t equals 0, so like that. It is known that h of 0 is equal to 4, so keep that in mind. That's the x value, that's the y value. Here. A portion of the slope field of the differential equation is provided. Sketch the slope of the curve at y h of t through the point 0, 4. So this one, only thing that you have to do is you just follow this. Do you see this point here, 0, 4? Yeah, only thing that you really have to do is you just follow this, okay? That's it. Number 1, that's it. So that's a 1 point. You're going to say, that's it? Yep, it is. Number 2, a point of 4025 shown that h of t is greater than 1. Find the value of t for 0, 5 at which h has a critical point, which means you're trying to, critical points means where f prime is equal to 0. Determine whether the critical point corresponds to the relative minimum. Relative minimum is when f prime goes to left, no, negative to positive, or relative maxima, this, or neither. Neither means like this, or like negative, negative, or like that's it, okay? Relative maxima, nor relative maxima, or the depth of the seawater location. Justify your answer. So this one, you just have to do it. So let's do this. We first have to find, we know that h of y is going to be greater than t. And it looks like we already have a slope. So dh dt is 1/2 h minus 1 times cosine of t over 2. All right, so let's do this. What we want to know is, for the critical point, we know this one should be equal to 0. So what I'm going to, instead of h of dh dt, I'm going to put 0 equals 1/2 h minus 1 times cosine of t over 2. What we know is, we know that h is greater than 1. So do you see this? This is greater than 1. So this whole thing, because it's a greater than 1, let's say 1.1. 1.1 minus 1 is positive. At 1/2 is still positive. So this whole thing is going to be positive. Here to here is going to be positive. I don't know what that is. Times cosine of t over 2. Should be equal to 0. So this one cannot be equal to 0 because it cannot even be 1, because this question clearly says h is greater than 1. So what we have to do is we have to make this one equal to 0. So 0 equals cosine of t over 2. Now the question is, when does cosine become 0? 0, pi over 2, pi, 3 pi over 2. So keep that in mind. It's not here. Cosine is x value. This one is a 0, 1. This is 0, negative 1. Cosine becomes 0 on pi over 2 and 3 pi over 2. Okay? But it's not t, it's a t over 2. So what you have to do is, t over 2 should be equal to pi over 2, because then this is going to be what? 0. Therefore, t is equal to, how do I get rid of this? Pi. Okay. What we know is that here, let's see if it is under the domain. Yep, it's under the domain, because it should be between 0 and 5, and pi is 3.14. So yeah. So that's it. So what I'm gonna write is for 0t pi from here to here, because here to here, that's gonna be positive, right? dh dt, which is our slope, t is greater than 0. And for pi to 5, because we want to know here between 0 and 5. Now, from here to here, like this, this is going to be negative value because it's going to be negative 1,0, right? So from pi to negative t, what we know is that dh dt is going to be less than 0. So since dh dt goes positive to negative, do you see? This one actually goes to the positive to negative at what point? At t equals pi, it is maximum. That's it. So even if you do not understand what's going on, if you can do this one, you're going to get a point. If you can do this, you're going to get a point. If you can do this, you're going to get full point. All right? I don't know how many points this is. I think you are going to get about 4 points for this one. All right? Let's do C. Use a separation of variable. Okay, so this is something that you guys have done a lot. dh dt equals 1/2 h minus 1 cosine of t over 2 with the initial value h of 0 equals 4. Yep, so let's do this. So you want to find particular solution for the differential equation, right? So you want to solve for h, because that's what question is asking, right? So let's solve for h. First, if you really want to do it, do you see this dh and h? That should go together. T and that should go together. So first, let me move this one to here. So it's going to be by what? Divide by h minus 1, multiply by 1 over h minus 1. And dt, this one times dt. So it's going to be 1 over h minus 1 dh, or you can simply put this one here, that's fine, is equal to 1/2 cosine of t over 2 dt. By the way, if you want to move this one to right here, just like 2 here, that's totally fine. So we have a dh here, so we have a dt here. So now we are going to take anti-derivative on both sides. So this is going to be natural log of h minus 1 plus c, but I don't care about plus c for now, is 1/2. Anti-derivative of cosine is sine. So it's going to be sine t over 2 divided by derivative of this, which is 1/2. But if you divide by 1/2, do you see these two disappear? So, or you can just multiply by 2, whichever you want, plus c. So that disappears. So we have natural log h minus 1. Oops, this one looks weird. H minus 1 equals sine t over 2 plus c. Now, you have an option. Would you like to plug this one in right now, or would you like to plug this one in later? It's totally up to you. For me, I'm not gonna plug this one in right now, but you can plug it right now and solve for C. It's up to you, because only reason that I don't want to go over this is because I know I'm gonna get rid of natural log by using beautiful curve, because it has a base E. base become a base. So I have e to the sine t over 2 plus c is equal to h minus 1. This is same thing as h minus 1 equals, whenever you have a plus c, you remember you can just write c times e to the sine t minus t over 2. And you're going to have h is equal to, actually, yeah, and then only thing that you got to do is a plus 1 on both sides. But let's plug this one in right now, 0, 4. So instead of h, I'm going to plug in 4. Instead of t, I'm going to plug in 0. So I'm going to put 4 minus 1 is equal to c times e to the sine of 0 over 2 is a 0. What's the sine of 0? Well, it's a 1, 0, so sine is a y value. This one is a 0. This whole thing becomes 0, which means e is 1. So 4 minus 1 is 3. C times e to the 0 power is 1. So c is equal to 3. Yep, so let's go back here. So we have h minus 1 is equal to 3 e to the sine t over 2. So if you do plus 1 on both sides, that's what you get. Right, so it's that easy. I believe this one is not extremely difficult for you to understand. So just a lot of work, okay? If I went over a little bit too fast, just watch the video again, okay? All right, so let's go to question number 4. This one is not that bad. I mean, this one looks challenging, but it's not. So let's do this. The graph of the differentiable function f shown for -6 to 7 has horizontal tangent at x equals -2. All right. For linear, and is linear for 0 less than or equal to 7, 0 less than or equal to x less than or equal to 7. The r is the region in second quadrant bounded by the graph of f vertical line x equals -6 or whatever. The function g is defined by g of this, function g becomes this. Find the value of g of 6, g of 4, okay. Oh my goodness, let's do this. So what we know is that g of x is equal to x of 0, f of t, dt, right? And this is the graph of f. So let's find it. G of -6 means, keep that in mind. Even before I go over this, this means g of x, it means, I cannot really do it, yeah. G of -6 is -6, 0, f of t dt, right? So when you do this one, you actually have to find the area under the curve, okay? Keep that in mind. What you're trying to find is the area under the curve, not the y value. Now, you cannot really have -6 on the top because always we gotta put small number on the bottom, higher number on the top. So this is same thing as -0, -6, f of t dt. Let's see. How do I find this one? What's that? 0 to -6? So, no, -6 to 0. Yeah, -6 to 0. It's going to be this one, right? Well, this one says reason R has an area of what? 12. So this is 12. But there's a negative in front, so it's going to be 12, which is -12. Okay, that's a 1 point. Now we have to find g of 4. So it's going to be 0 to 4, f of t dt. So let's do this. 0 to 4. So let's find area under the curve. It's a triangle. So base times height divided by 2. So 1/2, our base is what? 4. Height is 2. which is going to be 4. So on the maybe here, you really actually might want to write like this. Yeah, just make sure you write circle the like answers when you finalize, before you finalize it. And last one, we want to find g of 6. Well, it's gonna be this minus this, because this one is on the negative side. So this one is 1/2 2 times 1, which is 1. So it's gonna be same thing as the 4 minus 1, which is 3. So that's it. That's A. I believe this one is a 3 points question. All right. Let's do B. Says for the function g defined in the A, also you have to know A. Find all value of x in the interval 0 to 6, at which graph of g has a critical point. Give when do you have a critical? We have a critical point when f g prime is equal to 0. So let's do this one. I mean, you just want to find what g prime of x is equal to what? So g prime of x is what? Derivative of this, so derivative, so you're gonna just take a derivative of this, right? So g prime of x is derivative of this. When you take a derivative, derivative and this antiderivative onto each other, so you're gonna write f of, instead of t, now you're gonna use x times derivative of this, which is 1. Obviously, you got to do minus f of 0 times derivative of 0, which is a 0. So, but we don't have to write this, because always it's going to be this minus this. Yeah, so that's what it is. So you just want to find where this is what? Equal to 0, because that's where critical point is. Keep that in mind. Critical point is where f prime is equal to 0. Now, when do we equal to 0? I mean, do you see right here? This is the where f is equal to 0, right? Because this graph is keep on the positive, and here it becomes 0. Because g prime is f, so y value here. So you just write f of x, which is g prime of x, is equal to 0 at what? T equals, wait, should I say t? No, x, actually it's x. At x equals 4. That's it. That easy. Let's do C. That's the last question for question number 4. And I'm going to pause this video, okay? The function h is defined by h of x. We got this one, okay? Find the, oh my freaking goodness. So h of x equals antiderivative of x to the negative 6, f prime of t dt. Find the value of h of 6, h prime of 6, and h, oh gosh. Okay, let's do the h of 6. H of 6 is same thing as 6, negative 6, f prime of t dt. Now, do you see this is first derivative and this is antiderivative? So they undo each other, because here in the previous question, I couldn't really do it because this one is not first derivative. So I couldn't really do anything else. But here I can, because it's a derivative and this is antiderivative. So this is same thing as f of 6 minus f of negative 6. Which is here, f of 6, if you look at it, f of 6 is what? Negative 1. F of negative 6 is 0.5. So this is same thing as negative 1 minus 0.5. Don't you dare put negative 0.5. It's going to be negative 1.5, okay? You should really good at sign. So that's 1 point. Next one, it says, what does it say? H prime of 6. H prime of 6. So basically, you're just taking derivative of this. So derivative of this means derivative and antiderivative undo each other. So only thing that you are going to have left over is going to be f prime of x. But instead of x, you're going to plug in 6. What's f prime of 6? Well, so you want to find, that's a slope. So you want to find slope here. Well, it's a constant rate of change. So either you can use slope formula. You got this is 6 comma negative 1. You can say this is what? 0 comma 2. So you can use slope formula or you can use rise over run. It's up to you. Negative 1 minus 2 over 6 minus 0. Negative 1/2. It's that easy. I'm pretty sure next one was h double prime of 6 acceleration. Let's see. What's here. What's the acceleration? So what's the derivative of derivative? Look at this. Do you see this one's a linear? So for example, let's say this one is what? Let's say 1/2 x, right? Plus 2. When you take a derivative of this, if you take a derivative, because that's y prime, if you take derivative of this, you are gonna have, no, I'm sorry. This is the slope of this one is y is negative 1/2, which already we got, right? What's the y double prime gonna be? Derivative of the constant is what? 0, because as you can see, this is just negative 1/2, right? So it's gonna be what? 0. Since h prime of 6 is constant. Or you can just, if you don't like what I mean, you can just, yeah, that's it. Like if you don't understand what I mean, if f prime was like 2x minus 4, then f double prime is gonna be derivative of this, which is 2. You could have written like this. But as you can see, our first derivative is a negative 1/2. So when you take a derivative, you are gonna have just 0, because it's linear. Only because it is linear. All right. All right. So that's about it. If you have any question, let me know. I'll see if I can do more details. And good luck on your AP exam. Love you. I'll come back with question number 5 and 6. Love you guys. Bye.